Good morning, everybody. Sunday morning, Mike Stewart here. I just love being able to reach out to everybody and communicate this way. Um, I'm really looking forward, though, to being together next week. So, next week will be October. What day do we get together? October 5th. So, all of these online assignments will be due at that time. And then we're going to go back to doing face-to-face stuff. Right now is a point in the class where we're going to get into a lot more technical information. So there's a lot going on that we need to know about, and we need to know how to go look for this information. And when we do find it, we need to understand how it's written and how to interpolate a lot of this information. So that's what we're going to get into today. The furnace manuals for the trains will be posted on Blackboard, and in a couple future assignments, I will be posting assignments out of that furnace manual. But to get started right now, what I want to do is the carrier. This came off an old carrier furnace, old school furnace. It was actually a friend of mine's furnace. We took it out of his basement, and this fell out onto the driveway, and I picked it up and I said, hey, I think I can make a lesson out of this. And I did. So it's actually a very good, useful tool that we can use, this diagram. It's pretty common type electrical schematic, and it basically covers pretty much anything that you're going to run into as far as how to read a wiring diagram. So I'll get into this. So on the left side, see, this is with my cursor. If you follow my cursor, this is sectioned off into what, 4 different sections. And so we'll start here with a connection diagram. See, I highlighted that. It says connection diagram. And so that's basically all of this. That's our connection diagram. Over here on the right side is called a schematic. So you'll see the difference. These are the same. So the connection diagram has all of the same components and information as the schematic, but the schematic is written in a ladder type format, and it's more for a like a service person, like one of us, to come in. It's not an exact picture, but it's an exact representation of what you're going to see out in the field. So very seldom would I actually use a connection diagram. 99% of the time, everything would be done on a schematic, because once you know how to read this schematic or ladder diagram, it's actually a lot easier to use. So you'll see there's more information than what is printed in the schematic or in the diagram itself. And so you've got what's called the legend. I'll highlight that there, the legend. And on this particular unit, the legend is going to give us all of the abbreviations, because what's a GVR? A GVR. I can come down here to my legend and I can say GVR, main gas valve relay, DPSTNO. Well, isn't that interesting? So right now, we should know what a main gas valve is, right? So this is our main gas valve relay. So this right here is a control board. I can highlight that. This is our control board. And in that control board, there's a gas valve relay, so that energizes our main gas valve. You're gonna learn a lot more about this in electrical class. Hopefully this will be a good precursor to what you're going to learn in David's electrical class. But this is common terminology. It's DPST, and that means double pole, single throw. So double pole means there's basically 2 wires, and a single throw means there's only one, it's on or off type switch. It's normally open. NO means normally open. So we'll show you what that looks like coming up. So another thing too is, like right here, it says note 8. Note 8, JW9, it's pointing to JW9, note 8. So I'm going to go over here and say JW9 inducer off delay jumper. Cut 15-second delay, uncut 5-second delay. So I can adjust my inducer off delay, basically my post purge timing, by cutting a jumper right there. And then note 8 tells me, if I can read it, JW9 to be cut for 15-second inducer post purge for condensing furnaces. And this is an old school furnace. Nowadays they would become preset. So we've got the notes, the legend, and we've got the connection diagram, and we've got the schematic diagram. One other thing I want to show you is, like, over here it's going to give us a lot more details of, like, the wire. These are colors of the wire. So when I open the panel and I see a red wire and I say, huh, I wonder what that goes to. Well, I can look here and I can say, well, there's a red wire that goes to this LS and another red wire here that goes to the FR. We have another red wire. So these are all red wires and they're wired in series. So this, basically when a circuit goes through continually through switches like this, these switches are all in series. So if any one of them breaks, it could break the circuit. And when I look at this, so you'll see, let's look at this right here. That's a normally open switch. And so what do I mean by that? What do I mean by normally open? And over here, this one, I would say is normally closed. So this is a normally closed switch. And this one over here is a normally open. So do you see how the circuit is open? And you see how this one, it's a connection. So that's a closed switch. And what they mean by that is in the normal, like, what is normal? Normal could mean a lot of different things, especially in an electrical circuit. The normal position is in the off position. De-energized, no power in the off position, that's normal. Because when things are up and running, it could be in any one of a multiple, the normal position. So everything on this circuit is in the normal position right now because it's on a schematic or a diagram, and that you should consider to be de-energized, power's off, everything is in its normal state. So not tripped out on alarm, not locked out on some weird thing. The normal state is the system can run, but it's not running, power's off, and it's in its normal state. So this is normally open. And if you see the symbol, you'll get used to seeing a lot of these symbols, but I know because I've worked on this stuff before that this is a pressure switch. So if you look at this part that I'm highlighting right here, that is a sign for a pressure switch. And this particular switch is a low pressure switch versus what could be considered high pressure switches. And I can tell by the way it's drawn. See how it's down? So it'll break on a drop in pressure and it will make on a rise in pressure. If you see this right here, the action of that switch means that on a rise in pressure, the switch will make. So let's take a look at this ALS, auxiliary limit switch, overtemp, manual reset, single pole, single throw, normally closed. So this is a symbol for a temperature switch. See the little and the little tail piece? That's a temperature switch, and it opens on a temperature rise. Do you see how it's normally closed? Because it's showing me in the picture that it's closed. So it's a normally closed switch, and this is a symbol for temperature. So on a rise in temperature, the switch will break. or open. The switch will open on a rise in temperature. And I can tell that just by looking at it. I wouldn't even have to look at the schematic. Versus over here, this is a pressure switch that would make on a pressure increase, and it'll break on a pressure decrease. So here's a fuse disconnect switch. Fuse disconnect switch. So that's a fuse disconnect, normally open. And it's showing that that's fuse disconnect. That's just basically provides power to the entire unit. And it's showing it in the normally open position. Even though it's a manual, like a toggle switch, like the little light switch on the side of our furnace, that's what this is. And it's showing it in the open position. When it's running, it would be closed. So that's that. Let me move over. So I'm going to compare these two. Like I said, these two are the same essentially. If I look for ALS, it would be over here, ALS. It's going to show it right there. So see how much more compact this is? This isn't showing every single wire in the circuit. It's abbreviated. It is showing me the stuff that I need to know. Like I can see right now that there's these same 3 switches are in series. There's FRS, LS, all these switches are in series, these 3 switches. And see how this says note 6 when used, the same thing over here. So all of the information's the same, it's just in a different format. Now one thing that's interesting about a schematic, pay attention to this, because you will need to know it at some point in your life. You generally read left to right. So our power comes in on the left, and our common generally comes in on the right. Common being line 2. So line 1 comes down, and if you look at this, I'll highlight the top half. So the top half is our high voltage. This is the high voltage circuitry. And if you look at the bottom half, there's a transformer, and it says 24 VAC, 24 volts AC, and that's our control circuit, or our low voltage side. So we run our control voltage on a low voltage, 24 volt, because it's safe, there's less hazard, you can run smaller gauge wire, there's a lot of advantages to running 24 volts for your control circuit. And then our high voltage, this is a transformer, but our high voltage is 115 volts. So this top half is 115, bottom half is 24 volts. And you'll see over here, it's really no rhyme or reason. You could have, like, this is our low voltage, and over here some high voltage stuff. This is probably high voltage right here. This is probably high voltage. There's some low voltage. Here's the same transformer that I just pointed out. Right here's that same transformer. The cool thing about over here is it gives you like wire colors. Over here it's basically just going to give us the raw information that we might need. So let's look at this PRS. That's that same pressure switch that I just showed you. It's over here. PRS, normally open and common, and I know it's a normally open pressure switch. So what's interesting is right here is a PL1. So this is a plug, like a wire plug that you would plug 2 halves together, like a wiring harness plug. And so over here, I'll see PL1 is right there. See if we can find PL1. Yep, PL1 is right here. And that basically plugs into our control board. So this is a plug that plugs into our control board right here, PL1. So these are all connected, all these circuits are all connected by a wire to this plug. And then that plug plugs into our control board. Here's PL3. PL3 is another, it's a 2-wire plug. PL6. So in this circuit, look at this. So there's PL1, PL6, and PL2. Those are all in series with each other. So chances are it's going to through like multiple parts of the cabinet. And so rather than run a wire chase, they just plug the two together wherever it goes through a cabinet. That way you can keep things sealed off and probably easier for manufacturer. And then this is kind of old school, but it's showing, this is some of the internal circuitry in the control board. And then over here, we are going to get deep into how a thermostat works, but these are, for right now, you can look at this, these are our thermostat connections, R, W, Y, G, and C. So by the time you leave here, you'll be an expert on what those mean. Okay, so I hope this was as clear as it could be. And I have a worksheet. Some of this stuff I've already covered on your worksheet, so it should be easy. It's like some of the stuff on the worksheet, you're going to have to like hunt around. It's going to be a lot of digging around, getting in deep into these circuits. And you're going to have to know how to, you're going to have to refer to the notes. Like if you can't find something, don't give up. Just keep looking at the notes, look at these, look at the legend. There's a lot of good information, like in the legend. This is telling us terminals, unmarked terminals, a junction looks like that. Different types of wires are indicated by the thickness of the wire that's indicated here. So everybody can do this worksheet, and I hope you learned something. And when we come back to class, we're going to do a lot more. I'm going to do more on the with that Train manual, and then we're going to look into the how Train does their electrical schematics, which I always thought Train did probably the best job out of anybody. Okay, stay safe, and keep emailing me if you have questions or comments or concerns, and I'm looking forward to working with everybody throughout the week. Thank you.